This video covers the addition rule of probability, which is a way to determine the probability of events A or B, where OR is inclusive, which means that P, A, or B is going to be the probability of A plus the probability of B, and the equation also says to subtract the probability of A and B, and we'll see how that works in our examples coming up. So first we find the number of ways A can occur and do the probability of A, the total number of ways B can occur, which is the probability of B. We add those together, and the reason we subtract the probability of A and B is because if A and B can happen simultaneously, you're counting them twice if you do the probability of A plus the probability of B. You're counting the A and B with the A, and you're counting the A and B with the B, so you need to subtract one of those so you don't double count it. And that's where that equation comes from. It is possible that A and B cannot happen simultaneously, which means they are disjoint or mutually exclusive. That's down here. So if they're disjoint or mutually exclusive, they can't happen at the same time, so the probability of A and B equals 0. So if the probability of A and B is 0, then the probability of A or B is just simply the probability of A plus the probability of B. And we don't need to subtract anything because nothing was shared. So something that you can use to help you decide if events are overlapping or not is a Venn diagram. And we're going to scroll down a little bit and draw some. A Venn diagram is just a way to represent probabilities of events. And we start out with a rectangular box, and that represents our entire sample space. Okay, so the entire box, the probability equals 1. If you have mutually exclusive or disjoint events, you'll have A and B as separate events. There's no way that A and B can both happen together. So A and B are disjoint. The probability of A and B equals 0 because they can't happen together. So our probability of A or B is just the probability of A plus the probability of B. Now, in our sample space here, the probability outside the circles would be the probability of neither A or B. And that completes the sample space. So we could have A happen, we could have B happen, or we could have neither A nor B happen. And that is our entire box, our entire probability. So the other example is if we have events that can happen at the same time. So then we would have the probability of A and event B, and the overlapping space is the probability of A and B. Okay. So now you can see that when you calculate probabilities, if the probability of A and B is not 0, it's greater than 0. When you do the addition rule, the probability of A or B, if you do the probability of A, you're including everything in the circle of A. So all of A, which includes this overlapping space that's A and B. And if you do the probability of B, you're including the entire circle of B, including this overlapped space in B. So you see that we counted the overlapped space twice, which means we need to subtract it once so it's not double counted. So we're going to subtract the probability of A and B. And that is where that equation comes from. So just a quick example using a deck of cards. And I'm going to use the ace of hearts as my example. So the entire probability, this is an entire deck of cards without the jokers. So there's 52 possible cards. So we want the probability of a heart will be our probability of A. So hearts. And event B will be an ace. So let's calculate the probability of a heart. If you look at a deck of cards, there's 4 suits and each has 13 cards in it. So the probability of drawing a heart out of a deck of cards is 13 out of 52. In a deck of cards there's 4 of each card, so there's 4 aces out of a deck of 52 cards. And the overlapping space would be the ace of hearts. And there's 1 of those out of 52. So if we were to calculate the probability of drawing a heart or an ace from the deck, we would want the probability of drawing a heart plus the probability of drawing an ace minus the probability of drawing the ace of hearts, because we don't want to double count it. So that would be 13 out of 52 plus 4 out of 52 minus the overlap, which is 1 out of 52. And 13 plus 4 is 17, minus 1 is 16 out of 52 would be our probability for drawing a heart or an ace out of the deck of cards. So let's look at another example using a little bit different format. And this is a table of values. And we're going to be looking at a sports example. The NFL has coaches' challenges. If the coach disagrees with a call on the field, they can throw a challenge flag, and then the play will be reviewed, and the call can either be overturned, which would be a success for the coach, or a failure if the call is upheld. I have this divided into NFC teams and AFC teams. Okay. Those of you who are football fans will know what that means. If not, that's okay, you can still follow along. The first thing I'm going to do is calculate totals for my rows and columns. And I'm just going to add together across the rows. So the total here would be 56 plus 54 will give me 110. Total challenge flags thrown by NFC teams in 2011. And the AFC, if we add 48 and 39, we get a total of 87. The total number of overturned calls or successes would be 104, adding down the column. And then over here for failures, that'll give you a total of 93. Our overall total, if we add in either direction, and this is a nice way to check that you've done your math right, is the column totals and the row totals should both add to the same thing. So this is, again, 110 challenges by NFC teams, 87 challenges by AFC teams, 104 successes, and 93 failures, and 197 total challenges. So let's calculate some probabilities. First we can just do some simple ones. So what's the probability that a call was made by an NFC coach, or a challenge was made by an NFC coach? The total number of challenges by NFC teams was 110 from our totals row. And the total number of challenges was 197. So again, this is the number of ways that something occurred, so 110 challenges by NFC teams divided by the total number of events, 197 challenges. And we could do that for each individual thing that's in our table. So the probability that AFC was the one challenging, they did 87 out of 197 challenges. The probability that any particular one was overturned, I'm just going to write over to summarize or shorten that up. We had 104 of those out of a total of 197, and the probability of a call upheld is 93 out of 197. Okay, so again, those are just simple ones using the totals that we just added up. So let's look at some where we could narrow it down, and then we'll apply our addition rule to that. So let's say we want the probability that it was an NFC team and the call was overturned. So let's look in our table. The probability that an NFC was overturned, there's 56 events where an NFC's challenge resulted in an overturned call. We had 56, and then we want to take that out of our total number, which is 197. So again, these are not difficult either. If you are working with a table, the AND part is easy because you just find the box that refers to both of them happening together. So if we look at AFC and overturned, there are 48 in that box out of 197. Okay, so let's do something a little bit different on the next one. We can say, what's the probability that a call was overturned given that, and we just use a vertical line to represent given that the team that threw the challenge flag was an NFC team. When you have this part right here, we're going to look only at NFC outcomes, which means we're not going to look at the AFC in our probability. So the probability of being overturned, given that it's an NFC team that made the call, we're only going to look at the NFC part of the table, which is the first column, or first row, sorry. And what's the probability of being overturned given that it's an NFC team? The overturned number in that row is there were 56, and the total number of challenges by NFC teams was 110. Okay, so now instead of 197 on the bottom, you can see that changes. So when you have given, the bottom number of your fraction is not going to be the overall total anymore. It's only going to be the total of the outcomes you're interested in, which is the NFC outcomes. So let's do another one of those. We could do the probability of being upheld given that an AFC coach threw the challenge flag. Okay, so let's find that box, upheld and AFC. There's 39 of those. And now we want to take it out of only AFC teams, and our total of AFC teams is 87. So there's our probability for a call being upheld given that AFC challenged the call. So let's do one with the addition rule. What's the probability of an NFC team throwing a challenge flag or a call being overturned? Okay. So we have or, which means we can use our addition rule. So we're going to do the probability of NFC plus probability of overturned minus the probability of both of those, the and part. And the reason we need to include that is because if you look in our table, we have the probability of NFC or overturned. There's going to be some overlap because there's 56 ways, or 56 outcomes that were from the NFC and overturned. So we don't want to count them twice. So let's look at our calculation. So the probability of NFC we calculated earlier. That was 110 out of 197. The probability of overturn, we also took a look at that, 104 out of 197. And the probability of both, the probability of NFC and overturned, we also calculated earlier. It's 56 out of 197. And if you calculate that, we end up with 158 out of 197. Okay. You'll see if we didn't do that subtract of the overlap, we'd have 110 plus 104, which would give us 214 out of 197, and that's impossible. Probabilities have to be between 0 and 1. So if you ever get something greater than 1, check and make sure that you've done it with the correct equation. Okay. Now, we talked about the complementary rule in the last video. This would be a nice place to use it because the probability of NFC or being overturned covers everything in this column, the overturned, and everything in this row, the NFC. Okay. So these three boxes are being included in that calculation. Maybe a simpler way to do it would just be to look at the complement, or what is not NFC or overturned, because there's only one number left there. So we could do the complement which is the probability of being AFC and upheld, and do 1 minus that, because then again that's the complement. So we'd have 1 minus 39 out of 197. If we change 1 to a 197 over 197 fraction, so we can do some easier math here. Oops, this should be minus. We get 158 out of 197. So we can do it this way and get that answer, or we can do it by finding the complement and we can get the same answer.